Electricity and magnetism. That's the chapter of physics. And this is Electricity and Magnetism-1. And then we'll have 2 volumes of that. And this is the first volume. And the first thing we should understand is charges and force between charges. Electricity is related to charges. What is charge? Charge is a strange thing, really, given in nature. It is not seen or felt ordinarily. For example, if you touch a table, you feel no effect due to charge. Around 200 years back, charges were discovered to be in matter by the simplest process of rubbing two substances. Much later, they came to understand the fundamental essence of charges. This happened when they discovered that all matter is made up of atoms and molecules. Molecules are only atoms joined together. In an inch of any material, there are crores and crores of atoms or molecules. See the next chapter of atomic structure for more details. Now, electricity is a property of electrons and protons. Electrons and protons are in atoms. Electrons are negatively charged, protons are positively charged, and there's a third type of particle called neutrons. Neutrons have no charge, they have only mass. The negative and positive are only names to say that there are two kinds of charges. The protons and neutrons reside in a central nucleus. The electrons orbit around the nucleus. Now, the property of these two kinds of charges, positive and negative, is that positive and positive repel. They go away from each other. Negative and negative repel, and negative and positive attract. This is given in nature. That is a wonder. When two substances are rubbed with each other, electrons from one substance, say A, escape into another, say B. Now, B has now more electrons than protons, so it has negative charge. B has lost electrons, so it has more protons than electrons. So, A has lost electrons, so it has more protons than electrons. So, it has positive charge. You understand? Thus, A and B attract each other since they are unlike charges. If A is taken to a similarly negatively charged body, A and C repel. If B is taken close to a similarly positively charged body, D, then B and D also repel. Repulsion happens because like charges repel, similar charges repel. The force between charges, the repulsion or attraction, is called electrical force. The closer the charges are, greater the force. More the charges, the amount of charges. Suppose you combine two charges, the force will be more. This is expressed in the equation F is equal to K Q1 Q2 by R square, where Q and Q2 are the charges of the two bodies and R is the distance between them. This is called Coulomb's law. So now we have understood what is charge, and it's such a wonder, isn't it? And the force between the charges. Now let's go to currents, Ohm's law, and batteries. Currents are flow of charges in a conducting wire. It's a flow of charge. Charge flowing, moving in a conducting wire, in a metallic wire. How can such a flow of charges be created? Currents can be created using batteries. It was Volta who created the first battery. Working of a battery. A battery has three main parts: a positive electrode, a negative electrode, and a liquid or solid separating them called the electrolyte. The positive and negative electrodes are separated by the chemical electrolyte. It can be a liquid, but in an ordinary battery, it is more likely to be a dry powder. Now, when you connect the battery to a lamp and switch on, chemical reactions start happening. One of the reactions generates positive ions, charges, and electrons at the negative electrode. The positive ions flow through the electrolyte to the positive electrode. Meanwhile, the electrons flow round the outside circuit to the positive electrode and make the lamp light up on the way. The current in a wire is directly proportional to what is called a potential difference between 2 points. Now, potential difference, what is it? It is defined as a work done. It's a work done, the force into distance. The work done to carry a unit positive charge from one place to another. The more the potential difference, more the amount of current. The potential difference is called V, and V is directly proportional to I, and I is the current. And to make it equality, we say V is equal to I into R, where R is the resistance in the wire to the flow of current. R is actually literally the resistance. It resists the flow of the current. So we have got three variables, V, I and R. V is equal to IR. Current is measured in amperes, potential is measured in volts, resistance is measured in ohms. The relationship between potential and current is called Ohm's law. This is a very important law called Ohm's law. And that completes electricity 1. In the next section, physics, electricity and magnetism 2, we will see further principles and laws which govern electricity and magnetism, and they're very fascinating. Please visit Electricity and Magnetism 2. I hope you enjoyed the show. Thank you.